Hello! In this presentation I will show you how to perform the logistic regression analysis with SPSS. Briefly, the logistic regression is very similar with the linear regression. But please remember, the linear regression is used to explain and predict scale variables, also called continuous variables. But what if the outcome is a nominal variable with two categories? How can we predict a binary variable, such as yes or no variable? We can do it by using the logistic regression. So, let's begin. The objective of our analysis will be to find out if the model composed of income, number of absences, self-esteem and social support significantly predicts the presence or the absence of disciplinary violations, and which is the predictive value for each predictor. First, I will select Analyze, Regression, Binary Logistic. I will introduce disciplinary violations as a dependent variable and income, number of absences, self-esteem and social support as covariates. As you can see, below this area, we have the method of entering the independent variable into analysis. There is an enter method and also versions of the backward and the forward methods, which I have already described in the previous presentation, so I will not insist in this context. Also, this window has several additional options for this kind of analysis, but because this is a brief and practical course, I will stick with the essentials of this analysis and I will click OK. Now, let's see the results section. I will focus only upon the most important results. And the main table of interest here is the last table, called Variables in the Equation, which includes the main statistics of our model. In the first column, we have the B coefficients. These are the logistic regression coefficients expressed in log odds units, so they are not very suggestive regarding the predictive value of each predictor. In the second column, we have the standard errors for each regression coefficient, which is also not necessarily of great importance in our analysis. On the last column, we have the odds ratios. These coefficients are the most suggestive. They are obtained by the exponentiation of the B coefficients. Normally, the odds ratio is the ratio of two probabilities. The probability of an event in one group divided by the probability of the same event in another group. In our case, this event is the disciplinary violation. Now, let's interpret these odds ratios. In order to make their interpretation easier, let's imagine that our first predictor is not a continuous or scale predictor, but a categorical one with two categories, low income and high income. As you can see, the odds ratio for income is 1. Which means that the probability of committing disciplinary violations is the same in the high income group and in the low income group. But please remember that the income in our study is not a categorical variable but a continuous one. So the interpretation of the odds ratio equal to 1 will be a little bit different. So we will say that this value indicates that the probability of committing disciplinary violations is the same regardless the level of income per family. In other words, there is no relationship between the income of the families and the disciplinary violations committed by their adolescents. Now let's interpret the odds ratio for the other predictors. For the number of absences, you can see that the odds ratio is a little bit higher than 1, which means that as the number of absences increases, the probability of committing disciplinary violations also increases. For the self-esteem, you can see that the odds ratio has the value of 0.97, which is lower than 1. This means that the probability of committing disciplinary violations in the group of adolescents with high self-esteem which is the numerator of our ratio, is lower than the probability of committing disciplinary violations in the group with low self-esteem, which is the denominator of our ratio. In other words, as the self-esteem increases, the probability of committing disciplinary violations decreases. Finally, we have the social support. As you can see, we have an odds ratio of 0.96. Briefly, this means that when the social support received by the adolescents increases, the probability of committing disciplinary violations decreases. Finally, each regression coefficient and odds ratio is tested for significance using a Wald test, which has associated a level of significance. The p-values or the significance levels for each value of the Wald test, if smaller than 0.05, indicates that the regression coefficient is statistically significant. In our case, as you can see, the significant predictors are the number of absences and the social support, while the income and the self-esteem are not significant, the p-value or the significance levels for these values of the Wald test being higher than 0.05. Please remember that when we use several predictors in the same regression model, the regression coefficient for each predictor is obtained while controlling for the other predictors from the model. Another important table from this output is the table called Omnibus Test of Model Coefficients. This table contains an analysis about how good is our predictive model. The most important statistic here is the chi-square, which, if statistically significant, means that there is a significant relationship between our model and the dependent variable. In our case, the chi-square is statistically significant because its level of significance is lower than 0.05, so our relationship is statistically significant. Another important table here is the table called Model Summary. This table includes two pseudo r-squared values, which are the equivalent of the coefficient of determination in linear regression. So its normal interpretation should be the proportion from the dependent variable variance that is explained by our model, but several authors recommend caution when doing such interpretations. So, if we take for example the Nagelkerk R-square, it would indicate that our model explains 3.9% from the variance in the probability of committing disciplinary violations. So, briefly, these were the main statistical procedures for the logistic regression with SPSS. Don't forget to leave a review and see you in the next presentation.